Morning students, I am Meenakshi from Computer Science Department working in Rohini College of Engineering and Technology. So we are going to discuss some topics in the course CS 8603 Distributed System. So today's topic is Chord Protocol. So it comes under Unit 5. The learning objectives are to learn about the basic concepts behind Chord Protocol and to develop an algorithm for Chord. So what is Chord? So the Chord uses a flat key space. The use of Chord protocol is it is used to map the network node to the data object. So when the node joins the network or when the node leaves the network, we don't need to move all the nodes. Only the order of 1 by n keys have to be moved. This is the advantage of Chord protocol. So we have two steps in Chord protocol. In the first step, the object value is mapped to the key. In the second step, the key is mapped to a node. So usually the flat key space is used here. So the common address space used here is m-bit identifier. So you can use 2 power m addresses. And these addresses are arranged in a logical ring. So when you compute the successor of the key, we have to always apply the modulus operation. How the key is assigned to the node means the condition for assigning the key to the node is always the key is assigned to the first node such that the node identifier equals or is greater than key identifier k. Okay, so that is, for example, if k is equal to 10 and the node identifier is 8, you cannot map 10 to 8. So we move to the next node. Let the next node be 12. Since the node's identifier is greater than a key, so you can map the key 10 to the node 12. So this is the procedure. So how the key is mapped to the node. Okay. So assume this is one example. So we have so many nodes. They are named as N5, N18, etc. up to N119. So we have 6 keys, K8, K15 up to K121. So how we find out the successor means, so successor of 8. Successor of 8 cannot be a node 5 because the condition is the node's identifier must be greater than or equal to the key value. So we cannot map a key 8 to node 5. So obviously the successor of 8 is 18. Similarly, the successor of 15 is also 18. The successor of 28 is 28. Okay, so like that you can find out the successor. So we have two procedures in Chord. One is symbol lookup and the other one is scalable lookup. So in single lookup, each node tracks its successor on the ring. So initially, the query for the key X is forwarded on the ring. So the request is forwarded to every node until it reaches the first node. So what is the condition? The key value should be less than the node identifier. So that is the condition. Okay. So when we apply the computation, don't forget to apply the modulus operation also. So this mechanism requires order of one local space. It requires order of n hop movements. So this is the procedure. So the procedure name is locate.successor. So we call this procedure for the node I and for the key k. Okay. So if the key is in I, successor, then you can return the successor. Otherwise, you have to recursively call the same procedure for its key. So for example, we are looking up the key value 8 and the searching starts from the node N28. So K8, so it is not matching with N28. So the request is forwarded to the next node N53, N63. Again here also we can't find the match. So again it is forwarded to N73. So like that the request is forwarded. When it reaches N18, so you can know that the right place for mapping the key 8 is 18. Okay, the first nearest greatest integer, that is the best place to map the key 8 is N18. So in the node N18 we have the key K8 and the query is now satisfied. Okay. So in order to improve the algorithm, we go with scalable lookup code. So everything is same, but what's the difference mean? If the key is not in I, successor, then you don't need to call the same procedure. You have to call the separate procedure called closest preceding node. So what is closest preceding node means? It's used to find out a finger table entry from the finger table. So what is finger table? So how you build the finger table? See, for example, to build a finger table of 28, so initially you have to put the value 28. Then you have to add a 2 power 0, 2 power 1, 2 power 2, like that. Okay. So then you have to map the key 29. You have to find out the successor of the key 29. So the 29 successor is 63 and the 30 successor is also 63. Okay. But the successor of 28 plus 64, so it cannot be 63 or it cannot be 73, it is N99. So when we look up the key value K8, so we are looking up every finger in the finger table. We are looking up every finger in the finger table. So up to N99, we can't find out a match for the key K8. So it is waste to make a search for a particular key in the region N63 and N73. So we are skipping those entries and directly the query is forwarded to node 19. Again, to map the query, we are using a finger table of N99 to find out the suitable place for the key 8. So the best suitable place is node 5. Okay. So N104, N115, N63 all are unsuitable for the key 8. So we have decided to forward the query to N5. Again we are looking for the finger table of 5 in order to map the key 8. And we have concluded that the 8 is mapped to the node N18. So like that you have to find out entry for the key. So with this we are concluding the topic code protocol. Thank you.